Good afternoon. So I think only few students have joined. Still, your friends are joining. We will wait for 2 minutes, then we will continue. Let it be. So we will continue our class. Today I will start a new chapter, that is the gas power cycle. So if time permits, then I will go to the details of that exergy and energy. So because time is very less, so I'm trying to complete the gas power cycle. Then I will complete the steam power cycle, that is related to your Rankine cycle. So today we'll discuss the gas power cycle. Okay, so gas power cycle means, as the name is given, gas means in this case your working fluid will be the gas. So this gas can be generated due to the hot air. The hot air is in which your air is get compressed. Then after the compression, then we will add the fuel, so that there will be the hot air will be generated. That one is the one example. Another one is the in case of the petrol diesel engine, which is also known as the internal combustion engine. So in that case, we will supply the air and fuel mixture to the engine cylinder. So at the end of the compression, they will get compressed, and at the end of the compression, we will supply the ignition source in case of the petrol engine, so that those mixture will get compressed, and your in case of the expansion stroke, they will give the power. Okay, cycle means, in that case, all of you know that that is related to your in which your working fluid will after the it will be uh, in which your initial state will be equal to the final state. That means the working fluid will again come to its initial state and it will continuously move inside your engine. Okay. So in this case, you're working fluid with a gas, and this gas will never undergo any phase change process. So, like in case of your steam power cycle, which will I will discuss in the next class. So, in this case, the gas cycle will be it may be the ideal cyclic or it may be the non-cyclic. So engines can operate in two ways. One is your cyclic or another one is the non-cyclic. So cyclic means in which your working fluid will continuously move inside the engine. Non-cyclic means in this case, so after the achievement of your after doing work, that will be adjust to the atmosphere. Okay, so so that is a non-cyclic process. Okay, so if you are taking the example of your hot air engine, so that will be the cyclic engine, and another case is your petrol and diesel engine, which is also known as the internal combustion engine. That will be the non-cyclic engine. Non-cyclic engine means in which your fuel will be the combustion of the fuel will be sent. That will be the combustible mixture after doing work that will be exchanged to the atmosphere. Okay, so that working fluid will not circulate continuously inside the heat engine. So all of you know that gas power cycle is nothing but it is the heat engine. So the basic cycle for the heat engine is known as your Carnot cycle, right? Basic engine is your Carnot cycle. So in this case, if you remember, so it will have the two reversible isothermal process and two reversible adiabatic process, right? So if you have remember that PV plot, then it will look like this. Pressure volume, it is the property plot. So in that case, we have drawn like this, right? So 1 to 2 process is your isothermal heat addition process. It is added and it is the 2 to 3 process is the reversible adiabatic expansion process. In this case, we will get the expansion work. Then it is the 3 to 4 process is nothing but it is the reversible isothermal heat rejection process. So heat rejection we were taking Q2, and then where there will be the compression work. That is your WC, which is in the process of 4 to 1. So this one is the reversible adiabatic compression process. So this all the process which I have shown, it is in PV plot. If you are drawing in case of the TS plot, then it will be become the constant lines. All will be the constant lines. So first one is the reversible isothermal means your temperature will constant. So it is the 1 and 2. So this is the temperature is your, let us take it is the T1 temperature. Then we are having the reversible adiabatic process. So that will be also a constant line. So that is your 2 to 3 process. Okay. So in this case, your entropy is constant. And that will be the S2 and S3. Both will be same. In this case, reversible adiabatic process. So in this case, we will get the expansion work and it is the heat addition. Then we are having again the constant line. So that is your 3 to 4. This constant line is known as your isothermal, reversible isothermal line. So 3 to 4, in this case we are getting the heat rejection, that is your Q2. So the temperature in this case will be the T2, right? Here it is the T1 and this one is the T2. So again we are having the 4 to 1. So it is also constant line. So in this case, entropy is same. S1 is equal to your S4, right? So here better to write S1 is equal to S4. In this case, S2 is equal to S3. So in this case, there will be the compression work WC. So suppose we are considering the here the working fluid is your ideal gas. Ideal gas. So what will be the then heat addition and heat rejection? Also, we have to find out what is the expansion work and compression work. Then we have to find out what will be the efficiency of the Carnot cycle, right? So next, please find out what will be the heat addition. So heat addition is in case of the process 1 to 2. So for the process 1 to 2, I will write like this process. You can write it as the process 1 to 2. Then heat addition is your Q1. So Q1 will be, we will write as it is applicable for the first law to the process. Then your equation will be the internal energy change, that is your U2 minus U1 plus, in this case, your work will be the W. Okay, so work will be the W means it is a W12. Okay, expand on W12, better it is. We can write as W12. So in this case, U2 minus U1, here it will both will be equal. That is U2 U1 equal to U2 for the ideal gas. What is the reason? In this case, your temperature is your constant, right? T1 is constant. So temperature is constant means in this case, your internal energy change will be same. So it will become same means this term will get cancelled. 0, right? So what is remaining in the process, that is your Q1 is equal to your W12. So all of you know that this will be the PDB work. Reversible work means it is the PDB work. If you are taking at is the infinitesimal decimal heat transfer and it is a work transfer, then it will be the PDB. So suppose in the process you have taken the integration, that is the 1 to 2, then this will be the dq1 is equal to your integration of 1 to 2. This will be the PDB, right? So I can write it here. Q1 will be your how much it will be the as we have taken the working fluid is your ideal gas. For the ideal gas, we can write as PV equal to MRT, right? So here PV is equal to MRT means in this case, suppose M we have taken 1 kg of gas. So in this case, that will be the PV equal to RT. So instead of the P, we can write as it will be the RT V D V, right? So now instead of T, we can write as it is the T1. Okay, so heat is added at the isothermal process, that is the T1 temperature. If you are observing in this diagram, then this will be the T1, right? So at T1, integration of your dV upon V. So we will get as at T1 ln V2 upon V1. So this is the heat addition in case of the process 1 to 2. So which is the isothermal, reversible isothermal process. So here we have taken the working fluid as your ideal gas. So similarly, we can find the expansion work, that is your WE in the process 2 to 3. So again, please write down the equation for the process 2 to 3. So for the process 2 to 3, I can write it here. It is a reversible adiabatic means the heat transfer is your Q2 3 will be the 0, right? So if it is 0, then if you are writing the equation for the first application to the flow process, that will be the 0 is equal to your U3 minus U2, right? Plus your expansion work, that is we have taken 2 to 3, what is that your expansion work. So here we can write as it is the U3 minus U2. Instead of the U3 minus U2, we can write as it is the CV T3 minus T2. Okay, so if it is the CV T3 minus T2, then it will expansion work will be, we can write it as WT23 is equal to minus CV T3 minus T2. So this will be the expansion work. So why there is the minus sign? So all of you know that in expansion the internal energy, we will get the work output, right? So that's why here there will be the negative sign. So decrease in internal energy will be there. So that is your work expansion work, which is achieved in case of the reversible adiabatic process. Then if you are considering the process for in case of the 3 to 4, then your equation will be, so again there will be the heat rejection at the reversible isothermal process. So isothermal means T2 temperature. So here your internal energy will be both U3 is equal to U4. So that U4 minus U3 term will be 0, right? So then in this case your heat transfer can be represented as Q34 is equal to RT2 ln volume change, right? V4 upon V3. V4 upon V3. So I have omitted the step. You can write if possible. Okay. So like this, we have to derive for this Q3 4 also. Okay. So here it is RT2 ln V4 upon V3. So in this case, work will be the RT2 ln V4 upon V3, right? So then again for the process 4 to 1, it is the reversible adiabatic process, right? So in that case, heat transfer will be 0. That is Q for 1 will be 0. So similarly, I can write down the compression work, that is W41. So that will be achieved in expense of the internal energy. Okay, so that can I can write as CV, that is CV T1 minus T4. Okay, so this will be the compression work in case of the your reversible adiabatic process. Okay, so then we can find out what will be the W net. So W net, I can write it here. It will be the Q1 minus Q2. So which I can write as RT1 ln V2 upon V1, right? So similarly here RT2 ln V4 upon V3. Okay. So this will be the W net. So if you are taking the this V1 V1 sorry V2 upon V1 V4 upon V3 in terms of the temperature, then it will reduce to the another equation. So I'm not writing that part. Okay. So just remember this one. This is the W net. So like that we can also find out what will be the efficiency of this Carnot cycle when it is the working fluid is your ideal gas. Okay, so please find it by yourself. Then I will discuss the internal combustion engine, that is your mainly petrol and diesel engine. There are many gas power cycle which we are not discussing here. So those are your Stirling cycle. Stirling cycle. Okay. So in case of the Stirling cycle, we are having the two reversible isothermal, reversible isotherm, two reversible isochoric choric process, or we can write as isochlores also. Okay, so that is about your Stirling cycle. So in case of the two reversible isotherm was process, there will be the heat addition and heat rejection. Okay, so in case of the isochoric process, that means here your volume is constant. Okay, volume is constant. So in that case, your there will be the expansion and compression work. Okay, so then we are also having the Ericsson cycle. So it is also related to your gas power cycle. So these cycles are used to find as the for the hot air engines. We can use this cycle, then we can find out what will be the efficiency of that hot air engine. Okay, so Ericsson cycle also we are having. So in that case, we are having the two reversible isotherms. Two reversible isobars. Okay, so in this case, we are having this four process, two reversible isotherm, and we are having the two reversible isocores. Okay, so these two are utilized to find out the performance of the hot air engine. Okay, so now we will discuss the internal combustion engine. So basically, we are considering the reciprocating engine. Okay, so reciprocating engine. So in this case, mainly we will discuss the petrol engine and diesel engine. Again, we will discuss the high-speed diesel engine. Okay, so so all the three engine that can be analyzed with the help of the particular using particular cycle. So in case of the petrol engine, to do the thermodynamic analysis, we will use the Otto cycle. Okay, for the diesel engine, we will use the diesel cycle. So these thermodynamic cycle are used to analyze the performance of the engine. So here in case of the high-speed diesel engine, we will use the dual cycle. So these three cycle we are going to study here. Okay, so before that, I should explain what is the reciprocating engine, right? So I think all of you have idea about this reciprocating engine. Reciprocating engine basically it consists of the piston cylinder arrangement, right? It will have the piston cylinder arrangement, cylinder arrangement, or we can say that it is the piston cylinder device. Okay, so this reciprocating engine or piston cylinder device, these are used basically in major part of the automobile engine. So all of you know that these are the automobile engines. So there we are using different as per the different fuel used, these are classified petrol and diesel. These reciprocating engine are used in low speed engine to high speed engine. Okay, so lightweight vehicle to heavyweight vehicle. So starting from the passenger cars to the heavy trucks in Caterpillar engine. Okay, so I think all of you have idea about the Caterpillar engine. So there we are having also this reciprocating engine. We are also using the light aircrafts. Okay, so mainly we are using the gas turbine in case of the aircraft engine, but in for the light aircraft you can use the this piston cylinder device or reciprocating engine. So these are also widely used in case of the marine application. Marine application में mainly diesel engine हम use करते हैं. So then we are having the electric power generation. We will use this reciprocating engine, and like the many more applications are there for this reciprocating engine. So that's why we are analyzing the performance of that all those engine. So we have to use the basic cycle to find all those performance. So these are the basic thermodynamic cycle. So in case of the piston cylinder arrangement or device, we are having the different components. So which I'm going to discuss it here. So let us take it is the cylinder. Okay. So there we are having the piston. Inside the piston, inside the cylinder there will be the piston. So it one is the piston top. So which will continuously reciprocate inside this cylinder. So cylinder is covered by the cylinder head. Okay, so over which we will have the inlet valve as well as the exhaust valve, uh, which are mounted on the cylinder head. So if it is a petrol engine, there will be the use of the spark, and if it is a diesel engine, there will be the use of fuel injector. है ना, डीजल इंजन में आपका फ्यूल इंजेक्टर यूज होता है. So inlet valve means that the air fuel mixture will enter through this valve to the engine cylinder, and the exhaust valve means in the use of exhaust valve is the product of combustion. That product of combustion will leave the engine cylinder through this valve. So that is achieved in the exhaust stroke. Okay. So this piston may be the flat type, or it may be the ball type, or it may be the different re-entrant type. Okay. So many more arrangement will be there that is of different shape. So this piston is connected to the crank with the help of the connecting rod. So this one is the connecting rod. So it is the small end. This one is the big end, right? So it is connected to the your crank. Okay. Got my point. So what is the need of connection? So here the translational motion can be converted into the rotational motion. So that at the engine output shaft we will get the kinetic energy. Okay. So that is the conversion of translational motion to the your rotational motion. Okay. So this one is the connecting rod. So here the topmost position of the cylinder is known as your top dead center, and bottom one is your bottom dead center. So these two terms are utilized for the vertical engine. If it is the horizontal engine, suppose the engine is like this, horizontally placed. So piston is like this. Okay. So it will be here. It is the uh, um, outer dead center. It is the inner dead center. Okay, inner dead center, outer and inner. Got my point? If it is the horizontal engine. Okay, so this is the minimum volume up to which your piston will transfer within this cylinder. So it is the minimum volume means it is the clearance volume at up to which your product your air fuel mixture will get compressed. Okay, so that is the clearance volumes. Generally we use the so different components are used: cylinder head, inlet valve, exhaust valve, spark or injector, connecting rod, or we are having the crank mechanism. Okay, so these are the different components of your reciprocating engine. So top dead center, as I have already told you, we have to take the any reference point. Either you are taking from the crank or it from the cylinder head. So that point means from any reference point. Suppose this is the crank is the reference point. So from this point, the when your piston is near to the cylinder head, then that is known as your top dead center. So it is the fixed position of the reciprocating engine, where your piston will reciprocate inside the your cylinder, that is known as your bottom dead center. This one is the bottom dead center. So the here the position can be defined as the position of the piston when it forms the minimum volume. forms the when it forms the smallest volume in the cylinder, uh, sorry, largest volume, right? Top dead center largest volume करेगा और bottom dead center, sorry, bottom dead center largest, it will form the largest volume, and top dead center it will form the uh, um,
Minimum volume.
minimum volume. Okay, so that is known as your top dead center. So when your piston will move out from the top dead center and it is near to the crank position, then that is known as your bottom dead center. Then it will form the largest volume. Okay, so the distance between this your top dead center and bottom dead center is known as your stroke. Okay, known as your stroke. Okay, so the diameter of this piston is known as your bore. Okay, so these are the terminology used for the reciprocating engine. Got my point? So there is clearance volume means it is the minimum volume, and the largest volume formed by the piston is known as your sweat volume. Okay, so it is the sweat volume. Okay, so then we are having the term compression ratio,
And what volume?
sweat volume or displacement volume. Okay, so VS is known as your swept volume or displacement volume. So this volume is nothing but the volume displaced by the piston when it moves from the top dead center to bottom dead center. Okay, so that is your displacement volume. Then we are having the term compression ratio. So compression ratio is sometimes we are representing as in terms of the R, or sometimes we will write as the RK. So different notations are there. So compression ratio means it is the ratio of the two volume. One is your maximum volume, that is your sweat volume, to the minimum volume, that is the compression uh, volume. Okay, so the volume occupied at the minimum position. So that is the clearance volume. So this is also we will write as the V max upon your V min. Also we can write like this V VDC upon your V TDC, right? So this one is your compression ratio. So sometime when you are perhaps you have observed in case of the engine specification or car specification. So there this term will be mentioned, that is your compression ratio. And another one is the displacement volume. Okay, so displacement volume mainly we are representing in terms of the CC. So CC means it is the cubic capacity. So cubic capacity is nothing but it is the multiplication of your sweat volume with the number of cylinder. So number of cylinder. Okay, so that is your cubic capacity. So here the car or bike both can, if you are observed, there it is written 150 cc, 200 cc, and compression ratio is written as in some engine it is written as 20 is to 1, 17 is to 1, 22 is to 1, like that it is written. So that is nothing but that is the compression ratio, and CC is nothing but it is the displacement volume which is represented in terms of the cubic capacity. Okay, So there are other terms also, mean effective pressure, MEP. So MEP is nothing but it is the pressure acted upon the top of the piston during the expansion stroke. So that is known as your mean effective pressure. Okay, so there all of you have, if you have idea, there we are having the two-stroke engine, four-stroke engine, right? So two-stroke engine means your all the process will complete in the two movement of the piston. Four-stroke means it is the all the process will be occurred with the movement of the four movement of the piston. So when your piston is moving from top dead center to bottom dead center, then it is the completion of the one stroke. If it is moving from bottom dead center to top dead center, this is that is also known as your stroke. So that means within the cylinder, the movement of the piston from one dead center to another dead center is known as your stroke. So if we will discuss the all the process means there are the four process mainly occurred in case of the IC engine or petrol or diesel engine. Four process means, so first process is nothing but it is the suction. Four process or four operation. Then we are having the first is the suction. Then we are having the compression. Then we are having the combustion. Combustion generally we are not taking. So I'll discuss one by one. And compression. Then we are having the expansion. Then we are having the adjust. So all four process will occur in the four stroke of the piston, four movement of the piston. Suction means in this case your air will enter to the engine. Then again there will be the compression. Compression means piston will move from the bottom dead center to top dead center. Here the air will get compressed at the clearance volume, so it will gain the pressure and temperature. So at the end of the compression we will provide the fuel with the help of the injector. So this one is which I have told you now, that is the example of your diesel engine. So in that case only the air will get compressed. Okay, so at the end of the compression we are providing the fuel, so that high temperature of air is sufficient to burn the fuel, that is the diesel fuel. So due to the burning or combustion, the that gas will expand within the engine cylinder. During the expansion, that product of combustion will forces the piston downward. So during the expansion stroke, the piston will move from top dead center to bottom dead center. So the forces which are acting upon the top surface of the piston, so that is known as your mean effective pressure. Okay, got my point. So this area, the forces are acted upon the piston area. That means that is nothing but the pressure. So the mean effective pressure means the um, average pressure acted upon the piston top during the expansion stroke. So that is your expansion. So during the expansion stroke, we will get the work output at the engine shaft. Then again, we are having the exhaust stroke. In case of the exhaust stroke, your piston will move from bottom dead center to top dead center. So when piston is moving upward direction, so whatever the product of combustion are left inside the engine cylinder, that will expel, that will be exhaust to the outside. Okay, so outside of the engine, so it will adjust to the atmosphere. So all the four operation or process will be occurred with the movement of the piston. That piston will move four times. Okay, so each process will have the name as for the piston movement. So suction process will occur in suction stroke, compression process will occur in the compression stroke, expansion will occur in expansion stroke, like that in exhaust stroke. Okay, exhaust will occur in the exhaust stroke. So these four operation will occur with the full movement of the piston. So this I have taken for the four stroke engine. Got my point? So these are the different components or terminology which we have discussed for the reciprocating engine. So now we will discuss the working of your petrol engine or performance analysis of your petrol engine by using the thermodynamic cycle. That thermodynamic cycle is known as your Otto cycle. Okay. So, in case of the reciprocating engine, if we are discussing the petrol engine, so what will happen? So that process, that engine is non-cyclic one. Non-cyclic one means, in that case, the whatever the air fuel mixture or air is entering to the engine, that initial state will never again repeated as the final state. That means in that case, initial whatever the air fuel mixture we are entering, means we are giving to the engine, so that will leave as the product of combustion in the exhaust. Okay, so that's why it is the non-cyclic engine, non-cyclic heat engine. So Otto cycle is here we will refer the air standard cycle. So it is one type of air standard cycle. Air standard cycle. So what is air standard cycle? So air standard cycle means, in that case, we are simplifying the analysis of our reciprocating engine. So by using this cycle, so in this case, what we will use in this cycle, we will use the working fluid is a working fluid is our air. Okay. So whatever the properties of air is there, so that we have to use. That means in this case, the uh, specific heat of air at constant pressure, that will take 1.005. Okay, so whatever the specific heat at the constant pressure and constant volume will be there, that we will take for air only. So this specific heat at the constant pressure and constant volume, that will never change as per the temperature. So it will be remain constant. As we, here also we will consider that there will be no chemical change will possible, because air standard cycle is nothing but it is the ideal cycle or theoretical cycle. So in that case, we are neglecting all the um, chemical reaction and like that changes we are neglecting. Got my point? So molecular weight of air will be considered for the analysis. So the all the properties of air will be considered in case of Otto cycle, air standard cycle for the analysis of the heat engine. Okay. तो जो भी एयर का प्रॉपर्टीज कंसिडर कर रहे हैं एनालिसिस के लिए रेसिप्रोकेटिंग इंजन के लिए, तो उसको हम बोलते हैं एयर स्टैंडर्ड साइकिल. So Otto cycle is nothing but it is the air standard cycle. Okay. So in this case, it is related to the analysis of the heat engine, that is your petrol engine. So here we are having the four process: intake, compression, and your expansion and your exhaust. Okay. So generally it is a non-cyclic process. So in that case, we are having the two more process. One is your constant volume heat addition process. Okay. So I should draw the PV plot first. So in case of the PV plot, I will show you the different process. So in in our engine, we know that that is a non-cyclic process. So for that one, so we are neglecting the suction and your exhaust process. So if you are observing the PV diagram, first I am drawing the constant line. So what is that line? Let us take that is nothing but that process is 1 to 2. Okay, so 1 to 2 means in this case, first process is your suction. Your inlet valve will open, the air fuel mixture will enter to the engine. Okay, so that entry is a possible at the atmospheric pressure, constant atmospheric pressure. Okay, so 1 to 2 is the suction, then we are having the compression. Okay, so this one is the compression. So 2 to 3 process is the compression process. Air fuel mixture will get compressed up to the clearance volume. So I have kept this is as a clearance volume. Okay, आपका clearance volume, right? So here it is the top dead center. This one is the bottom dead center. Okay, top dead center and bottom dead center. So यहाँ के बीच में आपका क्या होगा? Sweat volume, right? So this is about your sweat volume, this is about your clearance volume. So up to the clearance volume, air fuel mixture will get compressed. Then there will be the heat addition. Heat addition is possible at the constant volume. Clearance volume में आपने compress किया, वहीं पे आपने spark provide किए, right? So that's why heat addition is at the constant volume. So the spark provide जो हम कर रहे हैं क्लियरेंस वॉल्यूम में, तो उसी को ही बोलते हैं कांस्टेंट हीट एडिशन. Okay, constant volume heat addition. So here it is the volume is constant, so we are providing the heat. So let us take that is the heat supply QS or Q1. So this process is, let us take it is the 4. Okay, so then we are having the after the heat addition there will be the combustion of the air fuel mixture. Then there will be the expansion due to the combustion of the air fuel mixture, right? So ये expansion हुआ mean piston will move from top dead center to bottom dead center, right? So that is your expansion process. Here we will get the work output. Then again we are having the process that is your 5 to 2. This process is known as your blow down. Blow down means at high pressure, if you are opening the valve, so what will happen? We have to provide the more work to expel out the burn gases. Okay, so that's why what we are doing, we are reducing the pressure up to the atmospheric pressure so that minimum work can be provided to expel out the burn gases. Okay, so here at constant pressure, your exhaust will be there. Okay, so then 2 to 1 will again your valve will open. 2 to 1 में आपका valve open हुआ means then your burnt gases will be expelled out. Okay, okay, or uh, exhaust will occur in this case. Exhaust of the burnt gases will occur in this case. 2 to 1. Okay, so this is the PV diagram for the auto cycle. Please remember this one. So if I am drawing the TS plot, so it will look like this. So in this case, the compression process is the reversible adiabatic process, and in this case, is the expansion process is the reversible adiabatic process. Okay, so reversible adiabatic means here your entropy is constant. In this case, your entropy is constant. So the first process is the reversible adiabatic means that entropy is constant. That I'm going to draw it here. 2 to 3 process, right? 2 to 3 process, right? Then we are having the constant volume, right? So in this case, we equal to C, constant volume heat addition, Q1 or QS, whatever may be. So I have taken it here, Q1. Then we are having the 4 position. Then there will be the reversible adiabatic expansion process, right? Again, we are having the constant volume heat rejection process. ठीक है right. With the expansion work, compression work, it is the heat rejection volume constant, right? So TS plot will look like this. So if you are able to simplify this one, then you can mark it as 1, 2, 3, 4 like that. है ना? इसको अगर यहाँ पे हम सिंप्लीफाई करके करेंगे 1, 2 करके करेंगे उसको ज्यादा बेहतर होगा समझने के लिए. Let me draw it again. P, B. Okay, so I have simplified this diagram. So if you are observing in this case, I have omitted the suction and your exhaust part. So if you are observing in this case, the area under this curve or this process is same. So this one is the positive and this one is the negative one. So what will be cancel out? So if it is possible, you can remove this one because in this case it is not required. So again, I have redrawn the PV diagram by neglecting this one. So I have taken the compression work is 81 to 2 and heat addition is the same as that of this diagram at the constant volume. So that is 2 to 3 process, right? So similarly, we are having the expansion, then we are having the heat rejection. So likewise, the this diagram will look like your complete cyclic heat engine जो हो रही है उसी के हिसाब से हमने ड्रॉ किया है. So this PV diagram again I have replotted in the case of the TS plot by considering that compression and expansion stroke. In that case, you are having the constant entropy, right? So then we have to find out what will be the heat addition. So in this case, suppose I want to find out the heat addition. So heat is added at the constant volume, right? So constant volume means there I can write as mCV T3 minus T2. Okay, it is the mCV dt. Okay, then dt will be T3 minus T2. So similarly, I can write down the heat rejection, that is your Q2, which I can which is also a the constant volume process. So that I can write it here M EV, right? So the temperature is your high temperature is T4 minus T1. So this is about your heat addition and this one is the heat rejection. Then I can find out what will be the efficiency of the Otto cycle, right? So efficiency of the Otto cycle I can write as 1 minus, it is the heat engine. So the equation will be the 1 minus Q2 upon your Q1. Right? Then it will equal to 1 minus MCV T4 minus T1 MCV T3 minus T2, right? Then it will be equal to, so this will get cancelled, that will be 1 minus T4 minus T1 upon your T3 minus T2. Okay, so this is the efficiency of Otto cycle. So as this process, a 1 to 2 process is your reversible adiabatic process. So in case of the reversible adiabatic process, the temperature and volume relation is your T2 upon T1. Reversible adiabatic में Pv to the power gamma, right? So Pv to the power gamma equal to constant. So if as per that relation, I am taking the temperature volume relation, then that will be equal to T2 upon T1, B1 upon B2 will be to the power gamma minus 1. So this is applicable for the reversible adiabatic process. ओके, तो उसी प्रोसेस में हम ये इक्वेशन यूज करेंगे। ये कैसे डिराइव किया गया है आप किए होंगे तो याद होगा तो कर लीजिएगा, नहीं तो इसको अगर डिटेल फिर डिराइव करने के लिए जाऊंगे टाइम लगेगा। ठीक है, सो दिस इज T2 upon T1. So why I am writing this one, I have to find the efficiency of Otto cycle in terms of the compression ratio. In terms of the temperature, we have got this relation. So in terms of the compression ratio, what will be the relation that I am going to find out, right? The next is your for the reversible adiabatic process. In this case is your 3 to 4, right? So 3 to 4 process में 3 to 4 process में I can write the temperature relation, that is a T3 upon T4 is your V4 upon V V4 upon V3, right? V4 upon V3 to the power gamma minus 1, है ना? तो यहाँ पे आप ऑब्जर्व करेंगे V1 upon V2, it is nothing but it is the maximum volume, right? It is the maximum volume to the minimum volume. यहाँ पे minimum volume है, ये maximum volume है. So this is nothing but it is the compression ratio RK. Okay, RK to the power gamma minus 1, है ना? V1 upon V2 is compression ratio. Then we have written as RK to the power gamma minus 1. Next, this one we have to simplify. So if you are observing V4 is nothing but V3, है ना? नहीं, यहाँ पे नहीं, ये तो टी प्लॉट है, ये है V4, राइट? V4 is equal to your V1, है ना? वॉल्यूम सेम है, right? So similarly here it is the V3 is equal to your V2, है ना? So in place of the V4 we can write as V1, in place of the V3 we can write as V2, है ना? तो V4 में लिखेंगे V1, देन V3 की जगह में V2 लिखेंगे टू द पावर गामा माइनस 1. Okay, got my point? So this will again equal to your RK to the power gamma minus 1. Okay. So if we are observing both the relation T2 upon T1 and T3 upon T4, both temperature ratio will be the same. So I can write it here. T2 upon T1 is equal to your 3T upon T4. Okay. So then what I will do, I have to bring this relation. So for that one, in this case, I will write as this T3 upon T2 is equal to your T4 upon T1. Okay. So then again I will do the minus 1 in this relation, T2 minus 1, T4, T1 minus 1. Okay, so this will be equal to here T3 minus T2, right? This will be the T2. Then this one will be the T4 minus T1 will be the T1. Then I can bring this relation. This will be the T4 minus T1 upon T3 minus T2. Okay. So T4 minus T1, T3 minus T2. This will be how much? This will be the T1, T2. T1 upon T2, right? So which is equal to your B2 upon B1 to the power gamma minus 1, which is 1, 1 upon RK to the power gamma minus 1, right? Okay. So now I can find out the efficiency of Otto cycle in terms of the compression ratio. So in place of the T4 minus T1 upon T3 minus T2, I can write as 1 1 upon RK to the power gamma minus 1, है ना? ये रिलेशन को हम लिख सकते हैं, ठीक है? So your efficiency of your Otto cycle is 1 minus 1 upon Rk to the power gamma minus 1. So this is the efficiency of your Otto cycle. So it will depend upon your compression ratio as well as the gamma value of the working fluid. Okay. So if your compression ratio is increasing, then your efficiency will also increase, but it will limit up to the certain level. The reason is that at the high compression ratio, that ignition of your air fuel mixture will be become complex. So it may auto ignite or premature ignition of the fuel will occur. So I'm not going to the details upon the premature ignition or auto ignition in this case. Only we have to derive our cycle and cycle efficiency. So this is about your auto cycle. Then we are having the diesel cycle. So diesel cycle means in this case we are having the PV plot as well as the TS plot. In this case, diesel cycle means here only air will get compressed. So at the end of the compression, at constant pressure, we will provide the fuel so that high temperature of air will enough to combust the fuel, and that combustion of fuel air mixture will form, and in expansion stroke we will get the work output. Okay, so that is the process in case of the diesel cycle. So यहाँ पे डिफरेंस क्या है, यहाँ पे कांस्टेंट प्रेशर में हीट एडिशन होती है. तो आप कभी अगर मैकट गए होंगे तो वहां पे जो इंजेक्टर का प्रेशर है 200 बार, 180 बार, 170 बार में सेट होती है. दैट मीन्स पर्टिकुलर इंजन के लिए हमारा जो फ्यूल इंजेक्शन प्रेशर है वो कांस्टेंट रहती है. आजकल तो कॉमन डीजल इंजेक्शन भी आ गए हैं, वहाँ जहाँ के कि आपका प्रेशर अप टू 1500 बार और उससे भी अधिक हो जाता है. तो that's why we are telling it as the fuel injection is occur at constant pressure. So that's why we are telling it as the constant pressure heat addition. So other two process will be remain same. other three process means suction आपका reversible adiabatic रहेगा, ठीक है. Expansion भी reversible adiabatic रहेगा. Then there is the what you we'll say that is the heat rejection. That is also at the constant volume. ठीक है, 1 to 2 3 4. डायग्राम ठीक से ड्रॉ नहीं कर पाए, ये थोड़ा ये नीचे तक आएगा. It will look like this 3 4 1. Okay, V1 V4 is same. Here we are having the heat rejection, expansion. This one is the compression. Okay, so for the here if we'll draw the TS plot, constant entropy 1 to 2, constant volume, heat addition. Okay, so sorry, constant pressure.
मैम ये 1500 बार क्या लिखे हो आप?
ये लिखे हैं जैसे कि आजकल कॉमन रेल डीजल इंजेक्शन वगैरह नहीं आ रही है, उसमें प्रेशर बहुत हाई रहती है. तो जैसे कि आप नॉर्मल जो सिंगल सिलेंडर इंजन का देखे होंगे घर कहीं पे, जो फार्मिंग पर्पस के लिए होती है, वहां पे 180 बार नहीं तो 200 बार का प्रेशर रहती है इंजेक्टर का, जो इंजेक्शन प्रेशर रहती है ना, फ्यूल इंजेक्शन प्रेशर. ठीक है.
तो मैम 1500 तक भी पहुंचा देते हैं. ओके.
So next is your diesel cycle. In this case, there is the constant pressure. This is the again reversible adiabatic expansion process 3 to 4. Then again we are having the constant volume.
मैम
Oh,
मैम 1500 बार पे जब फ्यूल इंजेक्ट करते हैं तो उतने प्रेशर से मतलब पिस्टन्स और सिलेंडर के बीच में जो थोड़ा सा गैप रहता है, इतने प्रेशर से उसमें लीकेज नहीं हो जाएगा?
ये कॉमन रेल डीजल इंजेक्शन है, बहुत सारे सिलेंडर रहते हैं, सिंगल सिलेंडर में नहीं है.
तो मैम किस में है?
कॉमन रेल डीजल इंजेक्शन.
ओके.
अब एक बार कैलकुल करके देख लीजिएगा, थोड़ा समझ में आ जाएगी. So this will be the Q2. Okay. So diesel cycle means in this case we are adding the heat at the constant pressure and we are rejecting the heat at the constant volume. So here we can write that heat addition Q1 will be the MCP T3 minus T2. So in case of the heat rejection, that will be the MCP T4 T1, sorry, T4 minus T1, right? So this will be the heat rejection. So in that case, in case of the Otto cycle also, you can find out what will be the network output. So I will discuss that one. Okay. So next we have to find out what will be the efficiency of the diesel cycle. Okay. So our heat engine formula is 1 minus Q2 upon Q1. This can be written as 1 minus MCV T4 minus T1, right? Then it is the heat addition MCP T3 minus T2. Okay, so this will be the efficiency of diesel engine. If you are observing in this case, will get cancelled. CB upon CP is 1 divided by gamma, right? So if I am simplifying this equation, then it will be the T4 minus T1. It is the gamma T3 minus T2. Okay, so it is the efficiency of the diesel cycle. So in this case, we will consider the different ratio. The first one is the compression ratio. So compression ratio is nothing but it is the ratio of the maximum volume, that is the V1 upon your V2. Okay. So then we are having the expansion ratio. In this case, that is RA. R is nothing but it is the V4 upon V3. Okay. V1 upon V3. Okay. Then we are having the cutoff ratio. So cutoff ratio is, it is the ratio of your end of the fuel injection to the minimum volume. Okay, so that is your V2. Okay, so that is your cutoff ratio. तो यहाँ पे आप देख सकते हैं कट ऑफ मीन्स your fuel injection will start at this point to at this point. Okay, so it is the this is the time up to which your fuel injection will occur. So it is the end of the fuel injection. So that is known as your cutoff volume. V3 is the cutoff volume, and this one is the minimum volume, V2 volume. Okay, the ratio of the cutoff volume and the minimum volume is known as your cutoff ratio. Okay, so these three ratio we have to consider, and we have to find out our efficiency of diesel engine in terms of this cutoff ratio and your compression ratio. Okay, so your compression ratio is nothing but it is the multiplication of the expansion ratio and your cutoff ratio. That's it. Okay, so in this case, we have to consider the individual process. So let us consider the first process is your um, uh, from the back side if you are writing, and let us take first process. Here we will consider the process 3 to 4. आप 1 to 2 से भी जा सकते हैं, मैं बैक साइड से कर रही हूँ. 3 to 4 process. In that case, the temperature relation is 3 to 4 is nothing but it is your reversible adiabatic process. So in case of the reversible adiabatic process, your temperature relation will be the T4 upon T3 is equal to your V3 upon V4 to the power gamma minus 1, right? So this one will be the V3 upon V4 will be nothing but it is a 1 upon expansion ratio. यहाँ पे हमने expansion ratio लिया है V4 upon V3. Okay, so it will be expansion ratio RA. So this gamma minus 1. Okay, so simply I can write it as 1 upon RA to the power gamma minus 1. So then this T4 temperature I can write is write like this. T3 is the multiplication of your 1 T3 1 upon RA to the power gamma minus 1. So again, if I am simplifying this one, expansion ratio in terms of the compression ratio and cutoff ratio, so it will look like this. R, this one is the multiplication of this, and then expansion ratio RA will be the RK RC, right? So so this will be the RC to the power gamma minus 1. This will be the RK to the power gamma minus 1. So T4 temperature in terms of the T3 temperature will be, and it will be the multiplication of the cutoff ratio and compression ratio. Okay. Then process 2 to 3. So in this case, process 2 to 3 means it is your constant pressure process 2 to 3. Here we have to consider the cutoff ratio. So cutoff ratio means it is the that is the ratio of your volume, right? So in terms of the temperature, if you are writing, that is your T2 upon your T3, so which is equal to your कांस्टेंट प्रेशर में टेम्परेचर वॉल्यूम का दोनों का V2 अपन V3 होगा, राइट? कांस्टेंट प्रेशर में ये रिलेशन होगा, ठीक है? So that will be the V2 upon V3 will be nothing but that is the 1 upon RC. So 2, 3 is a constant pressure process. So in case of the constant pressure process, we will get this relation T2 upon T3 is equal to your V2 upon V3, which is equal to your 1 upon RC cutoff ratio. Then T2 temperature also I can represent in terms of the T3 temperature, that will be the T3 multiplied with 1 upon R 1 upon RC cutoff ratio. Upon T2, okay, so which is equal to your V2 upon V1 to the power gamma minus 1. So this will be equal to R to the power Rk to the power gamma minus 1. So now if you are observing all the temperature we have got in relation of your volume ratio, cutoff ratio, compression ratio and expansion ratio. So this T1 I can write as T2 into 1 upon Rk to the power gamma minus 1. So in place of the T2, I can write as T3 into 1 divided by Rc Rk gamma minus 1, right? So all the temperature we have taken in terms of the T3 temperature. अगर आप ऊपर से आएंगे प्रोसेस 1 to 2 से कंसीडर करेंगे तो आपका ये T1 टेम्परेचर के रिलेशन में रहेगा, ठीक है? तो आप जैसे भी डिराइव कीजिए, आइदर प्रोसेस 1 to 2 से ले लीजिए, नहीं तो 3 to 4 से लीजिए। तो यहाँ पे आपका T3 टेम्परेचर कांस्टेंट करके हमने लिखा. So now I can write down that efficiency formula, that is your 1 minus your temperature was, this was T4 minus T1 upon gamma T3 minus T2, right? T4 minus T1 upon gamma T3 minus T2, okay? So this will be equal to your 1 minus, in place of the T4 I can write the equation T3 into Rc to the power gamma minus 1 upon Rk to the power gamma minus 1. T3 Rc to the power gamma minus 1 upon Rk to the power gamma minus 1, right? So then I can write as T1 temperature. So in place of the T1 temperature, I can write this relation. This will be the T3 1 upon Rc into 1 upon Rk to the power gamma minus 1, right? So then whole divided by, so this will be the gamma, it will remain like this. And T3, as I am taking the constant temperature of the gases, T3 will remain as it is. In place of the T2, I can write this relation. This is the T3 into 1 upon Rc. T3 1 upon Rc. So all the T3 will get cancelled. So you can simplify this relation. I can take the gamma outside this term, right? Then we are having the Rk to the power gamma minus 1. This will be come to here. So I'll take the common outside. Here also we are having this term 1 with Rk to the power gamma minus 1. So this will, the common will take outside Rk to the power gamma minus 1, right? Then we are having Rc to the power gamma minus 1. Here in this case it will be the minus 1, and in this case below RC to the power gamma minus 1, right? Minus 1. In this case, it will be the RC, and here it will be the R1 upon RC, right? Okay. इसको सिंप्लीफाई कीजिए तो कहीं पे एक मिसिंग है RC to the power minus 1 के कॉमन. Okay. Okay, this one I can write like this. ठीक है, इसको अगर हम सिंप्लीफाई कर रहे हैं तो गामा माइनस 1 मीन्स ये RC टू द पावर गामा into 1 divided by RC हो जाएगा. तो it will be taken outside. Okay. Okay, so the final term here it will be the only RC to the power gamma. To the power gamma. This will be the minus 1. Then in this case it will be the common, so it will be the RC minus 1, right? Okay, so we will get the efficiency of diesel cycle will be the 1 minus 1 to the power 1 minus 1 divided by gamma into 1 upon RK to the power gamma minus 1. Then it is multiplied with this value. So this value will always greater than 1 because RC is always greater than 1. Okay, so the efficiency of your diesel cycle will be always the higher value than the Otto cycle. So thermal efficiency of diesel cycle is always greater than the Otto cycle for the same compression ratio. The compression ratio for the same रहेगा तो गैप का और डीजल साइकिल का एफिशिएंसी ज्यादा रहती है. ठीक है, नाउ आई विल डिस्कस द डुअल साइकिल और विच इज आल्सो नोन एज द लिमिटेड प्रेशर साइकिल. डुअल साइकिल और okay, so this cycle is applicable for the high-speed diesel engine. So in which both heat addition will be there. Both heat addition means in case of the constant pressure as well as the constant volume. Okay, both केस में आपका हीट एडिशन रहेगा और बाकी जो प्रोसेस है वो सेम रहेगी. 1, 2, 3, 4, 5. Okay, here there will be the Q1. Here also Q1. This is the heat rejection. Q2. P, P. So next is your TS plot. TS plot में हम कैसे ड्रॉ करेंगे? फर्स्ट रिवर्सिबल एडियाबेटिक प्रोसेस आइसेंट्रोपिक प्रोसेस 1 to 2 हो गया, राइट? Then we are having the constant volume, then constant pressure 2 to 3, 4, 4 to 5, and यहाँ पे आपका constant volume heat rejection, iteration, sorry Q1. तो ये आप लोग खुद से फाइंड आउट करेंगे एफिशिएंसी. ठीक है, ये आप लोग का असाइनमेंट है. So this is for gas power cycle. Gas power cycle will be Carnot cycle. It may be the Stirling cycle or it may be the Ericsson cycle. So there for the reciprocating engine, we can find the 3 different types of cycle. One is the Otto cycle, then diesel cycle, then dual cycle or limited pressure cycle. So for the limited pressure cycle, we are having the heat addition in case of the constant volume as well as the constant pressure process. The other 3 processes will remain same. So you have to take the individual process, then you have to find out what will be the efficiency in terms of the temperature as well as the efficiency in terms of the volume ratio, that is the compression ratio, right? Compression ratio, then cutoff ratio, there is the expansion ratio. Here in this there will come another term, that is the pressure ratio. So that is the efficiency. So in case of the all the three cycle also we can find out what will be the work output. तो यहाँ पे मैं वर्क आउटपुट लिख देती हूँ. Okay. Work output means in case of the PV plot, we have to find out what is the work output. ऑटो साइकिल का एक कंसिडर कर लेते हैं, बाकी आप कर लीजिएगा.
Ma'am, in dual cycle, heat supplied from 2 to 3 and 3 to 4 are same.
नहीं सेम, मैंने लिख दिया है तो सेम नहीं रहती है. हीट सप्लाइड एक्चुअली लिख देना चाहिए था, तो ठीक है कि वो आपका एडिशन हो जाता है. सेम नहीं रहती है, ये कंफ्यूजन करेगा, तो आप एक इसको सप्लाइड कर लीजिए. सेम नहीं रहती है. ओके, सेम नहीं रहती है, अलग अलग रहती है. So here heat supplied will be the, it can be added. So in the process 2 to 3 to 2 to 3, this will be the constant volume means MCV T3 minus T2 plus, in case of the constant pressure means MCP, this will be the T4 minus T3. Okay, तो ये सेम नहीं है, ये ऐड हो गई. So this is your auto cycle 1, 2, 3, 4. So area under this curve or cycle will be the net work output. Okay, so net work output in the cycle. So how to find out this one? So first I will consider this process. This one is the 3 to 4 process. Okay, so it is the reversible adiabatic process. So in case of the reversible adiabatic process, what will be the work output? ऑलरेडी हम लोगों ने डिराइव किया था चैप्टर 1 में, चैप्टर 1 में 2 में. सो फॉर द रिवर्सिबल एडियाबेटिक 3 to 4 में क्या होगी?
P3 V3 minus P4 V4 by gamma minus 1.
P4 P4, right?
By
Gamma
gamma minus 1.
Okay, gamma minus 1. Who is given the answer?
Ma'am, Ayush Agrawal.
Okay, right. So similarly, in case of the process 1 to 2, that is your process 1 to 2, it is also reversible adiabatic process, so that is your completion work. So I can write it here, P2 V2 minus your P1 V1 upon gamma minus 1. So area under this curve कैसे आएगा? ये total 3 to 4. So this will be the, let me draw this one. Right. So first reversible work we have find out this one. Then we have to find the area under this curve 1 to 2. Then this will be the work. So this person it will get cancelled. So the total work in the cycle will be area under this cycle. Okay. So that is the net work. So I can write like this. Okay. So W net will be P3 minus P4 B4 gamma minus 1. It is the compression work, so it will become minus P2 V2 minus P1 V1 upon your gamma minus 1. So this is the net work in the cycle. Okay. So this you can also represent in terms of your compression ratio. So I'm not going to detail of it. Just not required. So similarly, you can also find out what will be the net work in case of the diesel cycle. Okay. So gas power cycle is over. So next class I will discuss the Rankine cycle. So all of you, please keep the steam table with you, and also the Mollier diagram, which I have already discussed in the properties of pure substance. तो जिस दिन डिस्कस कर रहे थे उस वक्त मैंने बताया था, तो स्टीम पावर साइकिल डिस्कस करने के टाइम में आपको वो चाहिए होंगे. ठीक है. थैंक यू ऑल.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am. Thank you,
Thank you,
ma'am.
ma'am.